And we're live! Okay, we are here. Gonna get my chips. You gotta plug it in. What happened? I think I stepped on my microphone and I unplugged it. So thank you for letting me know. There's always something at the beginning of these things. Let me go back here. So I'll start over. This is RockSim Live with Tim Van Milligan, your host who can't plug in a microphone. Back in business again, so everything's working on the website. So on the website, ApogeeRockets.com. Here's a link to RockSim right there in the front. Here is a link to the Launch Visualizer. The Launch Visualizer is our cloud version of the simulation part of RockSim, so you can launch on the launch field, away from your computer. If you have a cell phone or a tablet and you have Wi-Fi, you can run your simulations anywhere, anytime. Here's our newsletter sign up, which I encourage you to do. We put out a newsletter every week. So one week it's a newsletter, the printed newsletter, and the next week it is a video, so it alternates every week. We've been doing that since 2000, so well over 22 years. Here on our website we have our RockSim Live training. This is what we are in right now. click on it, it will bring up the archives of all of our previous episodes. So we are on episode number 71 today. Today is May 29th, I believe. Oh, it's the 27th. That is the 29th. 2 days ahead of myself. So we're the May 29th right now. And then once the episode is over, we'll go through it and find the various topics, and we'll if you want to download the software, there's a free trial. So you click on the How To and Guides menu bar, and come down to Software, and right here is a free trial you can download. We are on last week, right before our episode last week, I think it was last Tuesday, we released our latest version, 10.4. It was a free upgrade from 10.3. And it was also a free upgrade from version 9. So if you have version 9 or any of the version 10s, 10.0, 10.1, 10.2, or 10.3, those are all free upgrades to version 10.4. So you might as well get it. We fixed a lot of bugs. Yeah, we did a lot of work trying to get that one because there's a lot of people that were hesitant about upgrading until all the bugs were fixed. So we did our best to fix them. Whew. Okay, so that's where you can download a free trial. There's FAQs here, there's system requirements. We have verified now that RockSim 10.4 does run on Windows 11, so if you were hesitant about upgrading to Windows 11, it seems to work just fine. In fact, I've noticed there's been a speed increase on Windows 11 from Windows 10, which is always something good. What else? We have the video tutorials. Now these are different from our RockSim Live. These are more formalized, like how to, do things step by step. Those are the video tutorials. The RockSim Live training, which I'm on the page right now. There's also video tutorials for the RockSim Pro. So all that information is here under the How To and Guides menu. So that's where you'll find it. So let's go and see if there's any questions in the chat that I can answer. Don't kill carrots. I'd love to see that launch. I'm not sure what he's talking about. Tim, check chat. Says, I can't hear you. Need to push the mic connector. Okay, so the first 50 comments were about my stupidity on not being able to plug in my microphone cord. Okay, so let's see if there's any questions. Johan de Sloper says, I thought I would never do, but I probably build a mid-power soon. Oh, that's good. Build mid-power. Those are fun. We can get Polish composite motors now with loads, more impulse without a permit. That's great. That's great. Polish motors. You should be able to get the German motors in the Netherlands, Johan. That's Klima. They sell all over in Europe. They're nice motors. I visited them in 2016. It was awesome. 3D printer guy says, in the UK I discovered flying on private land. I don't need a cert at all. Yeah, I'm not sure about the UK laws. What we need cert for is certification is a safety certification. It's a safety program to make sure that you're able to build and fly rockets within the laws of the land, and not hurt anything. That's why we certify people to buy high-power motors. It's not so much a government regulation, but a regulation from the NAR other countries are adopting the same things, but I'm not sure about the UK. Also in the United States, like I said, you have to fly within the regulations of the country. In the United States, we have an organization called the FAA, Federal Aviation Administration, and they control the airspace. Anything that leaves the ground, they have jurisdiction over. So, rockets, kites, balloons, RC airplanes, all of it is regulated by, in the United States by the FAA. And high power rockets, anything that's over 1,500 grams, which is 3.3 pounds, or uses an H or bigger motor, has to be approved by the FAA to go up into their airspace. And so we call that getting a waiver. So there's laws, but the laws can be kind of waived in special occasions, and that's what a waiver is all about. So make sure you're flying within the rules of your country, because we don't want to see any government crack down on rocketry, because they could just ban it outright. You can't even buy motors or whatever. So that's what we want to avoid. That's why we get certified, safety certification. Somebody is saying my mic is still not working. E and F motors have no CE certification. Ooh, that's interesting. I didn't know that. Cert in the UK is for clubs. Audio faded out again. I'm looking at my indicator. My is going fine. Play with the cords. Tim, fix the mic cable. I'm seeing my level indicator. I'm switching microphones.
microphone. Testing 1, 2, 3, 4. Nope. Testing 1, 2, 3, 4. Testing 1, 2, 3, 4. I'm working on my microphone. Testing 1, 2, 3, 4. I'm going to use the microphone on the Macintosh. Is that one working? It's back. There it is. Brilliant. The new mic is working. I just unplugged the new mic. Mic is back. It's working now. I hear you now. Okay. Sorry about that. I did not. There's so many comments on the microphone that I wasn't sure if it's working or not. So, what was the last thing that you heard me say? Testing 1, 2, 3, 4. Yes, it's working. Okay. Okay, well, yes, it's working. Okay, I'm on the microphone on the Macintosh, so as I touch the computer, it's probably going to get a little bit of noise because, you know, the microphone is built into the keyboard. So, how to submit bug reports. So, it's easy to submit a bug report. First, you have to verify that you're on the latest version. We're on the Macintosh, it's 10.3. On the Windows, it's 10.4. Then what you do is you go to the Apogee website. Right here, the Apogee website. And you just come down here to contact form. Right over here, click on that. And it will bring up a contact form, and then there's a send email to line right here. Click on that. That's a drop-down menu. And then you can say, you know, RockSim general questions. And then you can type in, you know, RockSim bug report. And then put your message in there, you know, give your name and your email address. There's a CAPTCHA right here. And I know the CAPTCHA is a pain in the butt. The problem with, if we don't have a CAPTCHA, we just get inundated with spam because there's robots that look for contact forms and then they just spam them. So we have to have this stupid little CAPTCHA form. And it's a simple one. You just type in the letters, like right now it's displaying WBAFWZ, and it's all caps, no spaces or numbers. And then if you refresh it, you can get a different one. So this looks like a 0, but there's no numbers, so it's got to be an O. So that's how you figure it out. Okay. Phew. Okay, so any questions? Don't Kill Carrot says start over. Okay. 3D printer guy says, could I email the file for my G84 rocket for an opinion on it? And the answer is yes. So what you'll have to do, because my email is hidden, is just say, you know, again, this, because I'm not checking my email while I'm live, what you got to do is just do it under, you know, general information, or, you know, info or rocket help, and then type in, you know, put under the subject, say, let Tim know right now that you want to send a file, and they'll respond back to you with, when they respond back, you can just reply to that email. And then somebody will come in and knock on my door and let me know that there's file for me to look at, and then I'll check my email and then I'll be able to find it. So that is how to send me a file while we're live. Thomas Phillips says, RockSim question, how do I export plot data as CSV? Okay, I can answer that one. Okay, so first we need a simulation, so I'm going to open a design. RockSim designs. I'm just looking for a generic rocket here. Let's go with the Estes Astrocam. So this is an Estes Astrocam, and there's flight simulations here. Okay, so let's run a new simulation. I'm going to put in, so to run a new simulation, you click Prepare for Launch, choose an engine, and then you pick your rocket engine. I'll go with a Quest C18W, and I always pick the longest delay to start with, and then I back down after I know what it's going to do. Engine overhang. Engine overhang is how far back out the back end of the rocket the engine hangs, and I usually make that 1/2 of an inch. So I'm going to type in 0.5 inches and then click OK. And if you look here on the bottom of this image, you can see the engine is now installed, and in the back it's also installed here. I'm just looking at the flight events. We're going to deploy a maximum ejection delay. Starting state, we have a 36-inch launch rod, and let's go mostly straight up, and you can adjust the launch angle by spinning the wheel. Launch conditions, I got an 8-mile-an-hour wind coming on my screen. It's coming from the left going across to the right. And then I'm going to do flight profile. I just want to get a quick look at what this rocket looks like in its trajectory. Okay, so this is the 2D flight profile. The rocket is sitting right here. When I launch it, rocket takes off. It's going up. And 8 seconds after burnout, we should get the parachute, which it should be about right now. So here's the parachute out. That was pretty close to Apogee, so it's not too bad. And then I'm just speeding it up to see where it lands. Okay, so now what data is he talking about? So if you click on the details button over here, it will show you all this data. And anytime during the flight, you can see all the numbers are moving as the rocket's going up. And all that data can be exported. Anything that you see here can be exported. So I'm going to pause it again. So how do you export out this data? And it's not too hard. First I'm going to cancel that. So I'm going to plot it first just to show you what he's probably going to do with the data once he has it. Typically you would want to plot it out. So right now I'm going to do, my x-axis is going to be time, and we can do, you know, like thrust. Where's thrust? Here's thrust. We can do altitude. See, all these variables can be exported out, and they can also be plotted on a chart. So velocity, and go altitude. Where's altitude? Here's altitude, and I want to change my colors so that I can tell them apart. So I'm going to make altitude red. And this graph is going to end at 15 seconds in the flight. So it's past Apogee, the parachute's out, and you know, so this is what it looks like. So the green line is the thrust, the red line is altitude, and then the black line is the velocity. So the velocity peaks right around burnout, and then it starts coming down at Apogee. We still have a little bit of speed. It's not quite zero, and that's because the rocket is going horizontal. And then it comes over the top, and as it comes over the top and it's coming downwards, it's picking up speed again, and then right when the parachute comes out, then it starts slowing down, and then you get a constant descent rate as the parachute comes down. So that's typically what you want to do, is you want to make plots like this. But There's some things you can do with the raw data that you can't look at here in the plots, like comparing two simulations. You can overlay one simulation on top of another. You can't do that here in the plot. So to export out the data, you go to File, Export, and come on down here to Simulation Data, and then it's going to bring up this window where you have to tell it what is going to be the file name and where it's going to be stored on your computer. So right now on my computer, it's in the Documents folder in RockSim Designs under Astrocam, and if I wanted to move it, like if I wanted to move it to the desktop, click on Browse, and then find my desktop, click on the desktop, and then hit Save there, and right now, see, then it changed to a new location. So I always put things on the desktop. That's where I can always find them. And then now you can choose how much data you want. So right now, it's going to export out 2,000 points. So from 0 to from where it took off to where it touched down, I'm only going to export out 2,000 points. Because anything more than that is, you're not going to see a lot. But you might want more data than that. You're only going to, the maximum you're going to get though is the length and time of the flight. So my total flight time is over here under this column. I can see it says total. It's like 91 seconds. And then you have to multiply that times the sample rate. And let me cancel out of this. I'll show you the sample rate. The sample rate is, go to Prepare for Launch, and then it's under Simulation Controls. So the resolution is 800. So every second it's recording 800 individual pieces of information of all the, there was like 40 different variables. So of those 40 variables, each one has 800 entries in it while the rocket is going up. Once the parachute opens, then we're only recording one piece of information every second, because once it comes down on parachute, it's not changing. So we're only recording one sample every second. So while it's going up, and while it was going up, it was like 9 seconds. So you'll take 800 times 9. What was that? 72,000? No. Let me get a calculator so I get this right. 800 times, I'm taking 800 samples per second times 9 seconds, which is about the time it takes to get to Apogee. 7,200. I was right. 7,200 data points on the way up, and then it was like 91 seconds. So figure 91 points on the way down. So 7,291 is the most that I could export. And again, if we go to export simulation data, okay, so I'm going to, of that 7,200, I'm only going to export out 2,000 of them. The starting point is at time 0. The ending point is at the end of data. If you want to change it, you could say, when the rocket reaches Apogee, or when the first recovery device is deployed. Like I said, that would be 7,200 points. So if I wanted all of it, I would just type in 7,200. But you get so much data, it's going to be hard to manipulate. So 2,000 is probably a decent number. And then what do you want to export? I want to export time. I want to export thrust, maybe velocity, altitude. So you can pick what you want. You can export everything. Hit select all. Or you can just click on things you want to export, and then what you do is just click OK, and it exported it, and you can see it put it on my desktop. It has a CSV file. So if I go to my desktop, here's my desktop, Astrocam CSV, comma separated variables, I think we learned last week. If I click on it, it's going to open it up in a spreadsheet. So I'm just waiting for my program to open up here. And okay, so here is all the data. And I can just scroll through it. And it goes a long way. That's a lot of data, So once you get it into CSV, then it's up to you on how you want to manipulate it. We do have some tutorial files on how to manipulate data. I'll show you that real quick, where they're located. Because if you want to like merge two data sets together, so if you're on the Apogee website, go to How To and Guides, go down to Software and the Video Tutorials. And then there's a video tutorial in here. Let's see if I can find it for you. Okay, video number 20. Export simulation data to an Excel spreadsheet, which is a CSV file, and then combine the data to make graph comparisons. And I think I also did one. I did one in the newsletter for Google Docs. So if you don't have Excel, you can use Google Docs. To find that article, go to How To and Guides, Peak of Flight newsletter, then go to all newsletters over here, and this will give you a list of all 574 of them, and then you have to find the right one. So what I do to find the right one is on your keyboard, go Control F on Windows or Command F on the Mac, and that will bring up a little finder right up here. And then you can say, Google. It's not Sheets. I know there's one that's it's not too long ago that I did it. Data. Analyzing V2 data. It's somewhere in here. Calculating. What might have I used as the title of that article? Excel? No. I don't know. But you would find it, if you think about it enough, you'd find my article. Anyway, so that's how you export out as a CSV file. Let me see if I got any other questions here. Okay, Terry Wheelock says, how do we build a helicopter recovery rocket? In RockSim, you can't. Because RockSim doesn't, when the rocket's spinning like that and creating lift, we can't do that. It's just too hard to model. The only thing that you can do is kind of simulate a helicopter descent by using a parachute. And if you look at like the Helirock model, that's what I did. I cheated. Let me see if I can find it. Helirock rocket. Open. Save changes? No. Okay, so here's a helicopter design. And you can see it looks like it has blades that fold back. But I didn't even do it in here. But normally I would put in a parachute in the tube. Put a parachute in, and then it's a matter of figuring out how big of a parachute has the same descent rate as your spinning helicopter. So you need to do some tests. So right now I put in a 12-inch parachute, so I click OK. And then if I launch it, let me load an engine here, choose an engine, just like we did before, A10-3, click OK. I do have a flight event. It shows my parachute. And then if I launch it, see the flight profile, what it looks like. It will look just like we saw just previously, where the rocket, as soon as the parachute comes out, it's going to look like a parachute. It doesn't look like a helicopter. So on the way up, it should be fine. RockSim should be pretty close in calculating the altitude. But on the way down, you do have to figure out what your descent rate is of the spinning helicopter, and then put in an appropriate parachute for that same descent rate. So once you know the descent rate, say you put an altimeter, a recording altimeter into your rocket, and you measure the descent rate of your rocket. So then what you would do is you come here to design components, come to the parachute, and you'll see the descent rate right here. So you need to change the size of the canopy to match the correct descent rate. So if you're in feet per second, oops, it didn't change. Why didn't that change? Interesting. Huh, the other one changed. This one didn't. So that seems to be a little bug that I need to get fixed. So if I want a fast descent rate, I could just slide it, and you can see that the diameter of the parachute is changing. And if I want a slower descent rate, the diameter is getting bigger. If I wanted a 2-mile-an-hour descent rate, I'd need a 36 equivalent of a 36-inch parachute. Yeah, so that's how you would do it, how you would correctly size what parachute you would need. Pretty good question, though. Awesome. 3D printer guy says these RockSim lives are great to watch before going to bed. It's relaxing. Carlos K says, when I save a design with the engine hanging out 5mm, it never saves the engine position. What did I miss? I am not sure what you missed. It saves it with the rocket, so it's so once you set it for one rocket, it stays with that rocket, but the next rocket you open might be different. That's really all I can say about it. And I don't know why it's not saving it for you. Oops, I just crashed. That's not good. That was the one bug that we were trying to fix. So anyway, so if I go to, don't have to go to open a design right here. Come on, open. Go to designs. I'm just grabbing one. Century Jayhawk. That one looks interesting. And then I go to load an engine, and right now it's at 0.25. And let's make it 0.5. Let's put an engine in. I'll just grab something, doesn't matter. Launch it. Okay, I'm just going to save it. I'm going to open up a different design. I don't know, Estes Mars launch ship. Open that. And then if I go to load an engine into this one, here it's at 0.5. Let's choose an engine, D11 or D12, 7, launch it. Okay, and then I'm going to save that one. And if I go back and open that other one, that was the Century Jayhawk. Open. And we go to load an engine. It's set at 0.5. So it must use the last one that you input. So it's not the design dependent. See, I'm learning too. I thought it was design dependent. Although, let me cancel out this. If I go to that last one that I did and do an edit, when you do an edit simulation, it loads all the previous parameters. Nope, it didn't. It didn't save that one. No, it did, because I did use 0.5, didn't I? I can't remember what I did 2 seconds ago. Anyway, it's easy to change. It's just right here. I know it's annoying. I'll have to take a look at it. 3D Carlos K. Okay, I did that one. Hi says, do I need a good computer to use RockSim? The answer is no. Most computers can run it fine. Some older computers are just old and slow. I have a Windows 10 computer that I just absolutely hate using because in general it's just slow. But once you're running RockSim, it runs okay. But just going to like file open or saving stuff, that's part of the operating system. But it runs simulations just fine. Can we design and simulate dual rocket gliders, or do we just double a single design? Dual rocket glider. That's a good question. Okay, so I got a message here that says, just sent an email, the firefighter's still in the wrong station. That's not. I thought somebody sent me a file to look at. Let's see if the file came in. Well, I got a whole bunch of emails since I last logged in, but I don't see any files. Okay. Anyway, double glider design. Carlos K says RockSim does run great on old junky machines. Good. Yeah, now I got all these pop-ups coming up, so I got to quit out of my mail program. Okay, so glider designs. Last week I opened a glider design. You got to do gliders in RockSim Pro. So I went from RockSim here to RockSim Pro. It looks very much similar. RockSim Pro, the difference is it does 6 degree of freedom simulations, which gives you a lot more information about the rocket. And on a glider, because it can circle. We have to do gliders in RockSim Pro. And I had one that I was playing with. It was on my desktop. And I'm looking for, here we go, mini Condor boost glider. Open that. And I think I set this one up last week. Yeah. As a 2-stage rocket. So this is how you have to do a double glider. What I want to try to do, if both gliders come off at the same time, and obviously they are, I would, off the top of my head, I would say just doing one glider would be fine, unless the gliders are different. And if the gliders are different, then you do have to do both at the same time. So what I'm going to go through right now is a very, very advanced tactic, and I'm not sure if I'm going to be able to do it, but I'm going to try. So I have this glider here, and when we ran this glider last week, I'm not sure if it worked or not. So let's see if it works. So I have a booster stage, and this is the booster stage, and this is my upper stage. And when we did a launch simulation, I wanted to see what it looked like. And I think we had it glide. So what it's bringing up is a 3D version of the flight profile, but we call it the launch visualizer. So it's a little bit different because it's 3D. 3D means that I can rotate it around and see it from any perspective. And when I launch it, rocket takes off. Okay, so the pop pod fell off. Let me go to a trajectory view. So the trajectory view is this button right here, and then come over to this one. So I want to see the entire trajectory. And so the rocket is right here. It gives me, this is a launch site. I think it's up in Michigan. And if I zoom in, that little red dot right there is the launch pad. And if I keep zooming in, I'll get to this view right here. So you can see the rocket sitting on the pad. But I want to be far enough away where I can actually see what the rocket does. So the rocket's going to launch from right there. It takes off. You see the smoke. Oop, it went out of the screen. Okay, and now it is flying. So the red part is the pod, and the yellow part is the glider. And the glider is gliding around. Let me pause it right there and see if I can see the glider. So I need to move the glider here to the middle of the screen. Oops, too far. It's very touchy. And then zoom in. Too far. There it is. There's my glider. It's gliding around, and you can see the path that the glider is taking. It's not trimmed right because it's now starting to do a death dive. The one problem with the way this is set up is it's possible for the simulation to end, because the simulation ends when the upper stage hits the ground. And if the glider stays in the air longer than this takes to hit the ground, then we wouldn't see it gliding around. So you can see the ground track. It started here, went kind of to the north, then a little bit to the east. I can tell which way is north right here because the black pointer points north. So it went north, came to the east, then went kind of back north again, and then finally it's doing a nosedive into the ground. What I wanted to try to do was to put the glider as the upper stage instead of as the booster, so that no matter what, the glider, we could always track the glider. And then if the booster came down fast. So what I'm going to do is I'm going to go to the design components, and what I need to do is to swap these positions. I need to put the booster as the sustainer because that's the glider part. The glider part is all this. There's a lot of parts in the glider. You can see as I expand it. It doesn't look like much when everything's compressed, but this is the glider, and this is the pop pod. This could be really challenging. It could be really challenging. So what I'm going to do is I'm going to copy this fake tube, and this is the glider. I'm going to copy it, and I'm going to paste it here to the sustainer. File, edit, paste. Okay, so it did paste it right there. And then what I need to do is to take this nose cone and paste it down here. So I'm going to take this glider and I'm going to delete it, get rid of it. It's still showing right now because it's still right there. But then I'm going to take the pod and everything. The pod, if I just select the nose cone. No, I need to select more than that. I don't think the booster can start with a nose cone. Copy. I don't think I can paste that. Edit, paste. No, it didn't paste the nose cone. So to have a nose cone, I need to simulate that as a transition, because I can add a transition, but I can't add the nose cone. So I'm going to add a transition, and this will be, let me cancel out of that. It's going to be an elliptical shape. Front diameter is 0.543. 0.543. I'm looking at this number right here because this is the diameter of the tube. That's the rear diameter. The rear diameter is 0.543. 0.543. The front diameter, I want to make this as small as possible, so I try to get it to a point. So I'm going to use 0.01 and see what happens. And then the length is the length of the nose cone. I'm just going to call it, I don't know what it is. I'm going to call it 1.5 inches. And you can see it drew it right here. I think I wanted parabolic. Yeah, so it looks like a nose cone, but it's got a flat front end. And if I keep zooming in, I'd probably see it. See right there, it's flat. That's because my front diameter is 0.01. Okay, and then the material, we'll call it polystyrene. It's not solid, it's hollow. I'm just going through this really quick. Give it some weight. Okay, so we have a nose cone. We could have a shoulder on there. That's a 13 millimeter. And what did it do? It cleared out something. I made that the front shoulder. Clear front shoulder. Choose a compatible tube for the rear shoulder. Okay. And it's flopped it around. So let's go back here and flip these around. 0.01. Okay, so now it looks like a nose cone. Okay, I can live with that. Okay, I'm going to save this as a new design. I'm going to do save as. I'm going to call it glider version 2. I'm going to check to see if there's any questions. Johan says, suddenly curious what your age is, Tim. I'm 46 and my last job was operator of a power plant. I was told friends it was cool as launching a space shuttle, but I hate to fly and travel by boat. I am 10 years older than you. I'm 56. So I got a long way to go before I'm done though. Thomas Phillips asked, is there a way to upload custom motors into Launch Visualizer? The answer to that one, Thomas, is no. I could upload them myself, but we're not allowing users to do it yet. We need, because once a motor is there, the entire world can use that motor. And it can be confusing for people to see a motor in the database and not be able to buy it. So it's a self-imposed limitation. Eventually, what we want to do is give users the ability to store motors themselves, but we're not there yet. It's going to be that's a feature that's way down the road. In the meantime, I would just suggest input, find a motor that's as closest to the one that you want, that's your custom motor. That's how I would do it. Okay, and everybody else was talking about engine files, so I guess I didn't really have to answer that question. Thanks, everybody. I want to have somebody be a guest host on RockSim Live because I want to watch you use RockSim and RockSim Visualizer, the Launch Visualizer, and RockSim Pro. So if you want to volunteer to be a guest host, let me know. Okay, so we're building this. I'm rebuilding this glider. Now I'm going to take this body tube here. I'm going to copy it because I can. And I know I can attach that body tube to this transition. So I'm going to paste it, and it did paste it right there. And it pasted it just fine. Look at that. That's pretty good. So now I have two pods. See if I can rotate it around. Come on, don't ghost on me. Okay, so now I need to delete this pod up here at the front. Okay, so that's the transition. Wait a minute. What happened? Okay. That's right. Everything's okay. I need to get the fake tube up to the top. So I'm going to delete this body tube, and that's that one. Delete. Yes. So now I have two nose cones. Let me move this here in the middle. Now I'm going to delete that nose cone. Delete. Yes. Okay, so this fake tube, that is the start of my rocket. And that fake tube that used to be back here, because this is a two-stage rocket, and for a two-stage rocket I need a motor mount in each stage. So what I did was I created a fake tube so I could put in a fake motor for the glider. Now this fake tube, I still need a fake tube to put in my motor, but I don't need it so big. So right now it's got a diameter of 0.54 inches, so I can make this really small. I'm going to make it 0.01, and the inside diameter 0.009. So now it's like really tiny right there. But my problem is my glider location is in the wrong spot. So how do I move that? Okay, let me think about that. So the glider is the front of the rocket, and the rear of the rocket is the pod. This is where I might be stumped. I need to move the glider backwards. Let's see, I got a pod right here. Let me open this pod. Can I move that pod back? This is where I think I'm stumped. I need to think about this. Cancel. Because let me save this. I think I might revisit this on my free time over the weekend. What would happen if I launched it in this condition right now? So let's load engines. So I loaded the engines back into the glider. So here's my fake motor. Here's my real motor. And I wonder if it's going to go unstable. Let's find out. I got an A32 in the pod. Okay, so streamer at time relative to stage separation. I'll make it 0 seconds. So the streamer will come out right when it separates. And the staging is going to occur also when it separates. All right, let's see what happens if I launch. I have no idea what's going to happen, if the rocket's going to go unstable or not. And it just crashed. I mean the rocket crashed, not the software. It says it's unsafe. Yeah, see this crazy number right here. Didn't like that simulation is what happened. It's not going to load. There's the rocket sitting on the pad, and it's only going to be in the air 0.18 seconds, so it didn't like the simulation. It's just repeating over and over again. Okay, I'm going to come back to that. That was a good question, though. 'Cause I really would like to be able to track the glider all the way down to the ground. Instead of putting it at the bottom of the rocket, I want to put it at the top. 3D printer guy says, how about a Zoom call? Yeah, we can do Zoom calls. That's probably how we'd set up doing RockSim Live. We'd probably do something like that. Carlos says, I tried saving after specifying an overhang. It worked. Okay, so he found his way around it. All right, let's see if I've missed any questions. This has been a weird episode. I lost like the first 20 minutes just playing with my stupid microphone. I don't know why it wasn't working. It should have been. I'm looking at the questions here. Okay. There's a lot of questions that came in, a lot of viewers this week. I really appreciate that. Still looking for questions. We've gone an hour, but you know, like I said, that first 15-20 minutes was all screwed up because microphone problems. Okay. 3D printer guy says, did you get the RockSim file? Do you unplug the microphone into the laptop? That was a question. The microphone is actually plugged into my camera, and I know the camera's working, but then I have a built-in, you know, every computer has a built-in microphone, so that's what's working right now. I suspect the connector on the laptop is bad. No, it's not the connector on the laptop. It might be the connector in the microphone. I have to figure it out. I like using an external microphone because you get so much better sound quality when they work. Let me check my email, see if that RockSim file came in. I'll just double check. Let Tim know right now. Okay. I saw that. Or did I just see that? I got so many emails. There it is. Okay. I want to send to them when it comes attached. Okay. Okay, so he sent me this file. I better save that. Okay, so this file he sent me, I can't open. Attached message part. Oh, wrong one. No. Okay, so he wanted me to look at this file, so I'm looking at it. It's a little less than 2 inches in diameter, so that's kind of like a 54 millimeter. It's got a length, it's got a parachute up here. There's a mass object, here's the center of gravity, here's the center of pressure, and under the center of pressure, he's using the Barrowman stability equations, which is why it's blue on my machine. If I make it a RockSim, it turns red and moves back. They're both okay. Let's see what flights. He's not run any flight simulations. So if the question is, will this work? There's no reason why it shouldn't. This is, pretty generic looking rocket. It looks stable. Let's see if we load an engine. Oh, he's got a 38 millimeter motor in there. Choose an engine. We'll go with a G79. 13. Engine overhang of 0.5. Click OK. Flight events. Eject at maximum ejection delay. Launch rod is 36 inches long. I guess that's okay. Let's launch it. So there's the rocket, and it's running the simulations. Carlos says, when using 3D view, are there any tricks for metallic paints? Unfortunately, no. You could simulate it with a decal. You can make a metallic paint decal. I did that for one rocket. So the simulation is done. Here's the rocket sitting on the pad. We're still on that field there in Michigan. This rocket's going to go for 87 seconds, so it's going to go pretty good. Okay, so I'm kind of looking for the top of the weathercocking cone, because that kind of gives me an indication on how high the rocket's going to go in my view here. Okay, so the launch point is right down here, this little red dot. Click launch. Oop, it moved. It moved there. It's going up. Looks fine so far. Nice and straight. And somewhere the parachute will pop out. It's kind of, there it is, right there. Let me pause it. Oops, I stopped it. When you stop it, it jumps back to the beginning. Okay, so I want to see the rocket. So I'm going to go trajectory view. And then I'm going to find the rocket in the sky, and then I'm going to zoom in so we can see the rocket hanging by the parachute. Okay, so we have a blue rocket, blue parachute, because you didn't specify any colors. It's kind of bland, but it's fine. So here's the rocket coming down. So if you're just looking for an opinion on what the rocket is, it looks fine. Yeah, it's just fine. You should have a G84. Silver looks great, but gold just looks yellow. Yeah, it's because there's this thing called luminosity, and it's really hard to simulate metallics. Let's see, I think the Lock Magnum, or was it the Lock Ultimate? No, it was the Magnum. This is our website. This decal that's on this rocket, you know how you can buy holographic decal film? And well, that's what I didn't have any holographic decal film, so I made my own simulated decal by taking silver, which I do have, and then running it through my printer. And I just printed like a you know, on camouflage uniforms, it's like a bitmap of different colors. Well, that's what I did. I just, you know, I used red and yellow and green and blue just in random places, and it made like a, you know, it almost looks holographic in an image. So then, yeah, that's what I did. And then I don't think I did that in RockSim. I could take that decal file and then wrap it around the rocket, and it would kind of sorta look holographic. So you could do the same thing with metal flake paint. You know, just have, you know, like a red color, and then you put in like little pin pricks of white and yellow, and that might give you that metal flake look where, you know, where you have light reflecting off of it and gives you a nice little bright portion. 3D printer guy says it's called Miss Pinky, going to be bright pink. So to change it to a bright pink, I have the launch visualizer running in the background here somewhere, because it's there it is. I got the spinny ball. You have to change each component to bright pink. So you go to the nose cone, you go to color, and then you say 3D simple color, make it bright pink, you know, whatever pink you want. It's more purple than pink. Here's a pink. But if you want, you know, like a fluorescent color, maybe like that. And when you go back to 3D, now it's bright pink. So you got to do each component, but that's pretty easy to do. You only have a couple of components in this design. Although each of your fins, you did 4 separate fins. What I think you did was you took a fin set and you accidentally hit the button that says split, and that will split your 4 fins into, or the set into 4 fins. But the cool thing about doing this, though, is now you can color each fin individually. So if you had a rocket that had, you know, 1 pink fin, and 3 blue fins, that's how you would do it. Or if it had one, you know, a specific decal on it that was different from the decals on the other fins, that's how you do it. You take your normal fin set and split them by clicking the button called split, and then it will automatically split them, separate them here, and then you can adjust them, you know, individually at any given time. All right, so I think that's all the questions. Again, I'm sorry for screwing up with my mic. I'll try again next week. Yeah, so we will be back next week. Next week is, let me look at the calendar. We'll be into June. Come on, calendar, pop up. Waiting for my calendar to come up. My machine is running really slow today. June 3. So we will be back June 3 at 2 p.m. Mountain Time, which is in the United States. And if you're in the other part of the country, other part of the world, I guess you're going to have to figure out, just go to Google and type in, you know, what's 2 p.m. Mountain Time in my time zone, and it will tell you when we start. Have your questions ready. This is your show. I'm just here as the dummy behind the camera, trying to explain what's going on. So until next week, it's going to be a great Memorial Day weekend, although a little windy around here in Colorado, and I don't think we're going to be launching rockets because of the wind. But maybe, hopefully, but where you're launching, you can launch rockets. So in 5, 4, 3, 2, 1, go out and launch something.